Good morning, good afternoon, and good evening to all the folks who joined this presentation from different time zones. Thank you all for joining this talk, where I'll share some information about how Sila DB is being used at Strava. This is Faniteja Nalamothu. I'm a senior cloud engineer on the infrastructure team at Strava. I'm based in St. Louis, Missouri. I've been working in IT for just over a decade with interests in SRE, DevOps, AI ML ops, big data, and cloud engineering. And during my free time, I love playing cricket, poker, and I'm a huge lover of dogs. In this presentation, I'll talk a little bit about what Strava is and a brief architecture overview of the Strava platform and how ScyllaDB is being used at Strava, and I'll wrap it up with the benefits we've observed by using ScyllaDB. What is Strava? Strava is a subscription platform at the center of connected fitness, which enables athletes to connect with their community and compete. We are compatible with over 400 devices through which athletes can share data with their athletic community. Strava is part of every phase of athlete's life, like ranging from indoor, outdoor, training, recovery, and sleep. We have a couple of plans, a free plan as well as a subscription plan. In the subscription plan, we have some really cool features like segments, matched runs, heat maps, local legends, and route discovery. Our mantra is pretty simple. We believe people keep people active. We are the largest sports community in the world with more than 100 million athletes in 195 countries. We track more than 30 different activity types on the Strava platform. This number is constantly growing. We connect athletes to each other and help them find their personal best through group challenges, clubs, and leaderboards. Let's have a quick look at the architecture of Strava platform. We have requests coming in from the internet. They will hit the load balancer or through the CloudFront distribution, and then they will be routed to Linkerd. This is where all the magic happens. Linkerd handles all the authentication, authorization, and request routing. Strava is fully hosted on AWS. We use Apache Mesos on EC2 instances to manage all the microservices containers. Strava uses a wide variety of data stores like Amazon RDS MySQL, Redis, Memcache, S3, a few Cassandra clusters, and a lot of Scylla clusters. So how is ScyllaDB being used at Strava? I'd like to discuss a few use cases where ScyllaDB is being used. The first one is Horton. It's a funky name. All it does is store all the scalar values for activity data. Like any activity which an athlete uploads, like activity distance, max and average speed, heart rate, bike ID, shoe ID, anything which is a scalar value, it gets stored in Horton. You can look at the sample schema of this Horton database. We use athlete ID as a clustering column. This enables us in efficiently accessing all the athletes' activities from a single node. Frequently, we look up all the values for any activity. So this is a very good use case of Scylla. And the other query which we frequently do is range lookup, where we aggregate metrics like distance, time, and elevation across multiple activities or even multiple times. And a couple of other use cases I would like to talk are the segments and NeoGeo. Segments is where all the athletes' personal records are stored. And this is a very high write volume operation. I think ScyllaDB makes a good use case to store all this segments data. And the other one is NeoGeo, where we store encoded map styles for all the static images. This is a high read volume use case because these needs to be loaded on the feed. And the write volume is also pretty decent. It's once per activity. And what are the benefits we've observed by moving over to Scylla? The first one is it's much easier to migrate from Cassandra as Scylla API is compatible with Cassandra. We've also observed some increase in throughput after migrating to Scylla. We have experienced consistently low latencies in Scylla clusters, which were not possible with Cassandra. Whenever there is a GC pause in Cassandra, all reads and writes have to wait until the garbage collection is done. This has caused significant performance issues. The good thing is there are no GC pauses in Scylla. We serve over 100 million athletes, so we want our platform to be highly available all the time. Scylla achieves that. We can also achieve the same performance with fewer nodes, thereby reducing the admin costs and the operational complexity. We deploy most of our clusters in the US East 1 region in 1A, 1B, and 1C availability zones. We have quite a few microservices which use Scylla. They serve roughly around 30,000 read requests per second. We use the 2022.1.5 version of Scylla. Like our instance sizes vary from i4i.large all the way through i4i.8x large. And we vary these instances based on the load prediction. Scylla also comes with an enterprise version, which has Scylla Manager. It helps with automating the backups, managing multiple clusters, and also automating all the repetitive tasks. They also provide enterprise support and professional services. Thank you all for attending this presentation. Please get in touch with me if you need more information.